Hi, I'm Jared Marsaw, and I work on game technologies at Apple. Today, I'll be talking to you about how you can use select Apple frameworks to add new features to your Unity-based games. We know that many of you are using tools, such as Unity, to build your games. Our goal is to bring you the latest features no matter what tool you're using. Starting today, enhance your games with a new set of Unity plugins. Use the Game Center plugin to add GameKit features like player authentication, leaderboards, and matchmaking. Use the Game Controller plugin for input customizations and glyphs, along with support for MFI and third-party controllers. Use the Accessibility plugin to improve accessibility through system features like VoiceOver and Dynamic Type. Integrate Apple's data-driven, rich haptic feedback system with the Core Haptics plugin. Add advanced, geometry-aware spatial audio with the Phase plugin. Finally, use the Apple Core plugin to manage build settings and simplify the build process. This initial set of plugins will let you add new gameplay mechanics, make your games more accessible, and help you more rapidly tap into the latest features and services. I am extremely excited to see the amazing games you create with this new set of Unity plugins. Now, I'll get into the details of the project. First, I'll discuss the design principles of the project. Then I'll cover project concepts and organization. Next, I'll offer some key pointers on interacting with the project repository. And finally, I'll go into detail for each plugin. As you may know, Apple frameworks encapsulate functionality in a modular way. This lets you pick and choose the right technologies for your apps while maintaining compact, efficient code. With the Unity plugins, a similar pattern is followed. Each plugin maps to a single underlying framework. This lets you pick and choose the set of plugins you want to use based upon your game's needs. Each plugin exposes C#-based Unity script, which maps as directly as possible to the underlying framework. Doing this means that any familiarity that you might have with the underlying framework carries over to the plugin. Concepts, and in many cases the framework API, carry directly over. Conversely, this also means that by learning the plugin, you'll be implicitly learning the underlying framework. Another important detail is that these plugins are built as Apple Platform native libraries. These libraries act as the glue between the C# script and the underlying framework API. Apple Unity plugins are organized as Unity packages, so managing their integration to your project can be done with the Unity editor's built-in package manager. In some cases, plugins also include additional editor functionality that makes working with the plugin even easier and aligns with the Unity inspector-driven workflows that you're already familiar with. Of course, each plugin is paired with detailed readmes, samples, and links to additional resources, such as associated Apple developer documentation. Next, I'll briefly examine some key workflow concepts to help you get started. The first step is to clone the source from GitHub. You can find all of the project source and documentation there. This is the starting point for everyone who will be using the Apple Unity plugins. Once you've cloned the repository, building the plugins will be one of your first tasks. To simplify this process, the repository includes a Python script at the repository root, build.py. This script handles building native libraries, copying them to the correct locations, updating Unity metafiles, packing the plugins, and building plugin tests. The script is organized such that the simplest invocation builds all of the plugins, packages them into tarballs, and saves them to a build folder ready for integration into your Unity projects. It's important to note that fully building and packing the plugins will require Xcode, Python 3, NPM, and Unity. Finally, we have detailed documentation for using build.py in the project repository. Now it's time to dive into details with each of the plugins. For each plugin, I'll cover how to add them to your Unity projects, a brief overview of included features, key scripting concepts, and some code snippets or examples in the Unity editor highlighting how to integrate them into your projects. Let's start with the foundational plugin, Apple Core. Apple Core unifies build settings for each plugin into a single preference pane within Unity's project settings window. Because you compile each plugin's native libraries, Apple Core also includes an asset processor, which ensures that each plugin library is configured for the appropriate platform on import. When building your projects, Apple Core also contains scripts that run as a post-process to your build to ensure that native libraries are referenced correctly in your intermediate Xcode projects. Because each plugin interacts with an underlying framework, Apple Core also defines a handful of runtime interop types, which ease data passing between the C# script and native code layers. Finally, Apple Core is a dependency for all other Apple Unity plugins. This means that Apple Core should be imported into your projects before any of the other plugins. In this demo, I'll show you how to import the Apple Core plugin into a new project and briefly explore the Apple Build Settings preferences. Once the plugins are built and packed, Apple Core can be imported with the Unity Package Manager. Just choose the option to add package from Tarball and browse to the package plugin. The editor will then load the package and compile the scripts. Once complete, Apple Core is ready to use. Apple Core's primary user-facing feature is the addition of the Apple Build Settings tab in the editor's Project Settings window. When you import an Apple Unity plugin, all of its available build options will be visible here. Out of the box, Apple Core comes with some default configuration options, such as minimum supported OS version. It's also useful to note that you can disable the post-process build steps for any plugin. Finally, you can configure common security settings which will propagate to your intermediate Xcode projects. Use the Game Center plugin to bring even more fun and connection to your games with the Game Center, Apple's social gaming network. Game Center lets players build an identity across Apple platforms and enables features like safe, secure player authentication, in-game achievements, shared leaderboards, challenges sent between players, and multiplayer matchmaking. You can pick and choose which Game Center features to integrate into your games, but everything starts with player authentication. Add Game Center player authentication to your game, and the Game Center widget can feature your game on the player's home screen or within the App Store. It also requires very little code to add player authentication. The first step is to add the Apple Core and GameKit plugins to your project. The GameKit plugin connects the Game Center service. When authenticating, connect with the Game Center service and initialize a GK local player object. Once initialized, query for player restrictions based upon the local player's profile. These restrictions include limiting access to adult or explicit content for underage players, limiting access to multiplayer features, or disabling in-game communication. A simple way to manage a GK local player and its interactions with the Game Center service is to define a component within Unity. Here, for example, is a simple Game Manager component definition. This component holds a reference to a GK local player. It also handles both authentication and query for player restrictions in its start method. Player authentication only needs to happen once during the lifetime of the game. This is the Game Manager component script. Here's the field for caching a GK local player. Within the component start method is the one-time call to GK local player authenticate, a static method that returns the GK local player instance. Once the local player is successfully authenticated, it's time to check their player restrictions. Checking player restrictions in code resolves to a series of Boolean checks and can be added to the try block in the Game Manager component script. True here means your local player should have limited access to explicit content. True here means that your local player should have a restricted multiplayer experience. And finally, true here means that in-game communication should be disabled. And that's all the code changes necessary to add player authentication to your game. From here, there are 2 additional steps necessary to fully prepare your game to take advantage of Game Center. First, you'll need to add the Game Center capability to your intermediate Xcode projects. This is done from within the Xcode project UI. More information can be found in the Apple Developer Documentation article, Enabling and Configuring Game Center. Next, you'll need to add Game Center features to your app using App Store Connect. Check out the App Store Connect portal for more information. With these steps complete, you're ready to authenticate players and ensure a safe gaming environment. Player authentication only scratches the surface of the features made available by the Game Center Unity plugin. To learn more about improving discoverability of your game, check out the session Reach New Players with Game Center Dashboard. To learn more about multiplayer and matchmaking, watch the What's New in Game Center session from last year. Controllers are the primary way for players to interact with the worlds that you'll create. Easily bring reliable and flexible game controller support to your games with the Game Controller plugin. The Game Controller plugin brings a handful of features, like support for game controller customizations, which allow players to remap buttons in one place for all games, button glyphs to ensure consistent user experience, and support for all MFI controllers as well as third-party controllers like select Sony and Microsoft controllers. Just as with the other plugins, use the Package Manager to add the Apple Core and Game Controller plugins to your project. With the Game Controller plugin loaded, the first step is to initialize the GC Controller service. As we'll see shortly, this service is how controllers and their connection events are accessed. Once initialized, query GC Controller service for all controllers currently connected to the system. Connected controllers are represented by GC Controller objects in the Game Controller plugin. For each GC controller that's connected, poll for updated controller state. Polling can happen as little or as often as is needed by your game, but a good place to start is in Unity's regular update loop. Once controller state is updated, test for input on each of the controller's individual elements, such as buttons, thumbsticks, and so on. Not to be forgotten, controllers may come and go during your game's lifecycle. Register callbacks to handle controller connect and disconnect events. A quick way to get the Game Controller plugin integrated is to create a simple Input Manager component. This component has three key elements: a container which holds all of the currently connected controllers, a start method for initialization, and an update method for handling polling and testing for input. First, let's take a closer look at the start method. This is a great place to do all of the necessary one-time setup tasks. Initialization of the Game Controller service should happen here, along with the initial check for connected controllers, and registration of callbacks for connection and disconnection events. Here's the Input Manager component script. All of the one-time setup code goes in the component start method, including a call to gccontrollerservice.initialize. Calling getConnectedControllers gets an enumerable container of all the currently connected controllers. And the final initialization step is to register callbacks for controller connect and disconnect events. Now that initialization is complete, the Input Manager also needs an update method in order to poll each connected controller to update input state, and to handle input state for each of the controller's inputs. To poll for input, start by iterating through the set of connected controllers. Call the GC Controller's poll method to gather the latest state. Then check each button state and respond accordingly. And that's a quick look at how to use the Game Controller plugin to access connected controllers and get controller input. To get into more detail about the Game Controller framework and learn about topics like third-party controllers and non-standard inputs, check out prior year's sessions supporting new game controllers and advancements in game controllers. Accessibility is about making technologies available for everyone. Use the Accessibility plugin to integrate a wide range of Apple's assistive technologies into your Unity-based games. The Accessibility plugin gives you the ability to add key features such as VoiceOver, which can read programmatically tagged content to your users, Switch Control, allowing for a wide range of assistive input devices, Dynamic Type, to easily scale in-game text and UI based upon user preference, and UI accommodation settings in order to adhere to system-wide accessibility preferences. There's a lot to cover with the Accessibility plugin, so I encourage you to check out the session, Add Accessibility to Unity Games, for a deep dive into the Accessibility Unity plugin. In that session, you'll not only get examples and use cases, but you'll also build an understanding of what's possible with accessibility on Apple platforms. Be sure to check it out as soon as you have the opportunity. Adding haptic feedback to your games is a great way to increase immersion and enhance the gameplay experience. Integrate Apple's advanced haptic capabilities with the Core Haptics plugin. Use the Core Haptics plugin to build custom haptic patterns from a set of haptic and audio events, playback synchronized custom audio and haptics, programmatically define or update haptic feedback by adjusting parameters in real time. Use the Apple Haptic and Audio Pattern File Format, or AHAP, for a file-based approach to designing and storing your patterns as assets. Tune your Core Haptics patterns in the Unity editor with inspector support. To get the most out of the Core Haptics plugin, you'll need to understand 4 fundamental elements of Core Haptics and their relationship to one another. The highest level element is the CH Haptic engine. The Haptic engine represents the link to the haptic server on the device and is required to play any haptic patterns. The CH Haptic engine creates CH Haptic pattern players. Pattern players are used for playback of CH Haptic patterns with controls like start, stop, pause, and resume. A CH Haptic pattern is a logical grouping of one or more haptic and audio events. The CH Haptic engine uses patterns to create players. CH Haptic events are the building blocks used to define a haptic experience. Core Haptics is a data-driven API, which allows for haptic patterns to be defined programmatically directly in your scripts, or by leveraging AHAP files. One easy way to add Core Haptics support to your projects is to create a haptics component that manages each of the necessary Core Haptics objects. Here's an example haptics component that contains a CH Haptic engine, a CH Haptic pattern player, and an AHAP asset. The AHAP asset is a custom Unity asset defined by the Core Haptics plugin. This allows for easy import and export to AHAP files, as well as a custom editor extension to manage pattern creation and customization. Let's take a closer look. I'll begin by ensuring that both the Apple Core and Core Haptics plugins are installed in my project. With those added, I can start enhancing my game with haptics. Here's the haptics component that I've created based upon the previous diagram. We'll check out the implementation in just a moment, but for now, I'll attach it to my airplane. Once attached, I now see that the component requires an AHAP asset, but my AHAP assets folder is empty. I'll create a new one by going to Assets, Create, Apple, Core Haptics, AHAP. Once created, I'll give it a fantastic and original name, My Haptic Pattern. The Core Haptics plugin comes with editor extensions that let me tune my new pattern right in the inspector window. This is where I define the CH Haptic events that are part of the CH Haptic pattern that can be played. By default, there's a transient event, but I can easily add a continuous event as well. There are also import, export, and reset buttons in the UI. Reset clears any events that I've added and returns the pattern to its default state. Import and export are great features. These allow your project to load and save AHAP files. Here I've imported a predefined AHAP called Rumble, which triggers a nice vibration effect, but I think it needs to be tweaked just a little bit. Now that I've updated the pattern, I can export it to a new AHAP file in order to share this improved haptic pattern with the rest of my team. Now that my asset is created and tuned, I'll go back to my airplane and point it to my haptic pattern. Great, everything is wired up. With the haptic pattern defined and properly referenced, All that remains is to add some logic to the haptics component so it can play a haptic pattern. This can be divided into two methods: prepare haptics and play. Prepare haptics is where the haptic engine is initialized and the haptic pattern player is created. Play will simply call the chHaptic pattern player's start method to begin playback. And here's the haptics component script. Fields are defined for a haptic engine and a haptic player. Importantly, add a serialized field attribute to allow the ahap asset to be set in the editor UI. Next, add the code to create a chHaptic engine, start it, and create a haptic pattern player by accessing the ahap directly from the referenced asset. Of course, calling start on the player will play the haptic pattern. The Core Haptics Unity plugin gives you the tools you need to add an entirely new level of immersion into your games. Use the Core Haptics plugin to create magical game moments that look, sound, and feel real. For a deep dive into Core Haptics, check out the session Introducing Core Haptics. For details on designing engaging haptics experiences, be sure to watch Designing Audio Haptic Experiences and Practice Audio Haptic Design. Immersive audio is an incredibly important aspect of great game experiences. Use the Phase Unity plugin to unlock your creative potential and build lush soundscapes into your game worlds. With Phase, you can provide complex and dynamic audio experiences to your games. Geometry-aware audio means that sounds emanate from and interact with meshes in the scene. Environments in your game will sound more realistic through reverberation and reflection. You can build hierarchical audio graphs that allow for dynamic audio control during gameplay. The Phase plugin includes a set of predefined components that are game-ready. Simply attach them to your game objects, and you can start using Phase without writing a single line of code. The first component is the Phase Listener component. It acts as the ears of your game scene and processes audio based upon its position, orientation, and reverb preset. Next is the Phase Occluder component. Phase occluders attach to game objects with geometry data and dampen audio when they come between sources and the listener in the scene. Next is the Phase Source component. These are attached to game objects and use the object's transform to position sounds in your game world. In addition to the built-in components, the Phase plugin also defines a custom asset, the Sound Event asset. Sound events are objects which describe audio playback events and define the audio played by sources in the scene. To start using the Phase plugin, the first step is to make sure that both the Apple Core and Phase plugins are added to the project. Once installed, I can start adding the included components to the scene. In this example project, I have 3 game objects of interest: an airplane, a building, and a camera. First, I'll attach the Phase Listener component to the camera. By doing that, I've added the ears to the scene. Next, I'll make the building an occluder by attaching the Phase Occluder component. Finally, I'll add a source to the scene by adding the Phase Source component to the airplane. Now that I've added a source, it needs some audio to play, so I need to attach a sound event, but the sound events folder is empty. I can create one by going to Assets, Create, Apple, Phase, Sound Event. After creating a sound event, the Phase plugin will immediately open the Phase Sound Event Composer window. This is the canvas used to build sound events. I start by right-clicking anywhere in the window. This shows a pop-up that allows me to add a node to the event. Because I want to play back a clip, I'll create a sampler node. I've already added an audio clip of an idling airplane to the project, so I can reference that here. I'll keep looping enabled so that the airplane keeps humming along. To hear the airplane, I need to route it to a mixer. I can create a mixer by dragging the output line onto the Event Composer's canvas, where it will show me the option to create a mixer. My sound event is now complete and ready to use. By clicking on the sound event, I can see its settings directly in the inspector. This allows me to adjust values without having to go back into the sound event composer. With the sound event created, I can now reference it in the phase source component I attached to the airplane earlier. And with that, audio in the scene is routed and configured for playback. The Phase Unity plugin opens totally new possibilities for in-game audio design. To learn more about Phase and to dive deeper into the concepts I've introduced today, be sure to check out the Apple Developer Documentation site and last year's introductory WWDC session video. And that concludes our overview of the new Apple Unity plugins. I've covered a lot today, but if you'd like to know more about any of the Apple Unity plugins, the repository on GitHub is the best place to start. That's where you'll find the source, detailed documentation, and samples for each of the plugins. Find out more about integrating accessibility into your Unity games with the Add Accessibility to Unity Games session. And be sure to check out Reach New Players with Game Center Dashboard to learn how to boost your game's visibility. Thank you for watching.